talk to you with that thing in your mouth.
X is less than -2?
That's what it says, yeah.
Okay.
So number
I know what it is.
one.
Okay, then do it. Ready? Ready, what?
Wait, I don't know the top.
What, ready?
Top equation is number one.
F
Why do you need
equals.
one?
No,
There is a number one. Well, -5, -2, so, oh, okay. Number one is.
F equals -5.
I don't know what you're saying with that.
Show me.
That means
Yes.
X is not 5. Negative is not worth negative. Oh, wait. Sorry. Look at calculator real quick. And then number 2.
Wait, one calculator, negative
Sure.
Find F -5, find F
So those are the three problems
Yeah,
you're working there where Riley's talking about.
If the X is less than that, or that, that would just problem.
So what is number 1?
More than that, and
It's minus 2.
so F.
I don't.
Yes. I don't think. I believe so. Greater than or equal to negative. And 7 is greater than. We haven't even gone to the actual first.
That's her.
5 times 7. I don't know what.
These are called piecewise functions.
Did I do it right?
Do these equal to those numbers, or do you plug those numbers in?
To me, these are pretty easy.
Plug it in. You plug it in.
Only some of
I can't remember. So I got 24, -7, and 38. I got 26, -7, 40. Some should be higher. Oh, maybe. Oh, 30. I'm just gonna wait for you to explain this. That's right. I'm energized, not that energized. I got 38. Did you get 38? I'm not 40.
Alright, so we're gonna start looking at some new types of functions with this unit this week. And so this first one is called Piecewise Functions. P-I-E-C-E, it's up there on the board where it is every day. So this, bell ringer that you started off with is actually a piecewise function. Get it put up here. All a piecewise function means is we're gonna show different pieces of the function. In this case, it's, well, what we're gonna do today is graph them when they're lines. But anyway, so we'll use this piece of the function when x is smaller than -2. So that's a piece of it. That's over to the left of -2. You'll use this piece if x is greater than or equal to -2. So that's to the right of -2. So all you had to do was determine which function these fit into. So you say -5. Is -5 smaller than -2?
Yep.
Yes, so you plug the -5 in there. -5 squared is 25. 25 minus 1 is 24. So you would get 24, right? Okay. -2. Is -2 less than -2? No. Is -2 greater than or equal to -2? Yes, so we plug the -2 in here. 5 times -2 is -10. -10 plus 3 is -7. Okay? 7. Is 7 less than -2? No. Is 7 greater than or equal to -2? Yes. So 5 times 7 is 35. 35 plus 3 is 38. Okay, so not that difficult, right? Just have to see which piece you're using. So now we're going to actually graph some of these piecewise functions.
Do we need graph paper?
If you have some, it would be helpful.
last time we should not use that, but I'm what we said the number.
It all hooks together some way or another. Where's my graph paper? Oh, I gotta turn the background white first, I forgot.
So, but we're not gonna have a test over that stuff, right?
Correct.
So we have to show this section right over.
Sounds like a plan.
I usually tape off. Do you have any tape?
Not right now. It's another minute.
So this is unit 1.
This is what now? Well, we're actually in unit 3.
Sure.
Okay, so our directions here say to graph the piecewise function, then identify the domain and the range. So like I told you, everything that we're going to graph today is going to be linear. So remember f of x is the same as y, y'all know that. Y is equal to x, so we got to graph that line. And then y is equal to negative 2x plus 1, we got to graph that line. But we only want to show pieces of those lines. On the first one, we only want to show the piece where it is smaller than negative 3. On the second one, we only show the piece where it's bigger than negative 3. So what I'm going to do, x is negative 3, and you don't have to do this, but it helps me because I'm a simple brain. I'm going to move over 1, 2, 3, and just put me a little dotted line there, just so I'll know that's the line I'm concerned with, because that's my rule up here. See up here where that's got x is less than or equal to negative 3, and x is greater than or equal to negative 3. I got to be concerned about x is negative 3, don't I? I might erase that in a minute, but I just want to know where it is to start with. Okay, now both of those lines are in slope-intercept form. Y equals x, that's mx plus b form. What's the b if there's not one written? Up here on this line. 0, so I'll go to the origin and put a dot. What's the slope? How many x's if there's not a number in front of it? 1, so from that dot I rise 1, run 1. So that's just going to be a diagonal line going like that. Now, before I draw my line, I want to see where I need to draw it to. This tells me to graph this piece of the line where I am less than negative 3. So here's my negative 3 dot, my negative 3 line. Are these dots less on the less than side of it? Are these dots on the less than side of this line? No, less than's to the left, right? So I don't want to graph this line on this side. I want to find out where this line will be over here. Okay, so I'm going to continue the slope until I get this line over here. So I can just keep going with my slope there. Down 1, right 1. I'm still not there. Down 1.
Question.
Yes.
What is that dotted line?
X equals negative 3.
Oh.
Because that was in the rules. I'm almost there. Down. Okay, so now I'm on the dotted line, right? Let me go a little bit more to draw my line. Okay, so to the left. So that line will be looking like that. And all these points over here now, I don't need because they don't fit the rule. The rule said x had to be less than or equal to negative 3. Now pay attention to that less than or equal to, because that determines if we have a colored in circle or an open circle. So on this first line that's down here on the bottom that you can't currently see, should my circle be colored in or open?
Colored.
Colored in, because it says less than or equal to. So that should be colored in, and I need to show that from here I can keep going forever. Now you know how to graph a line. That's not a big deal. We just had to show only the piece it asked us to show. And we're not done with this function because now we got to do the bottom one. Yes.
So if it's less than or equal to, it's open.
No. If it's got the equal bar, you color it in. If it doesn't have the equal bar, you leave it open. All right. So this line, where does it cross the y-axis? 1. So go up to 1 and put a dot. Then what's its slope? I'm going to go down 2, right 1. Okay, now this line wants me to show this part of the line that's greater than -3. So greater than -3 would be to the right. Okay, so I'm gonna be able to show this part. Let me go ahead and make my slope go the other way as well a couple times. Okay. Now, when this line hits up here, way it's going to be up there on the ceiling on mine, would its circle be colored in or open? Open, because it doesn't have the equal bar underneath it, right? Okay, so let me get a line and draw through here. That goes forever. So let me scroll it so we can see both of our pieces. The only thing I might do now to make my answer look a little better is then go and erase my dotted line, but you don't have to because it's not as easy for y'all to erase on your paper. So not anything new, you just got to know which part of the line you're showing. Okay, let's try another one. Yep, in the second. Second. You got it, sir. Alright, let's try. Just name this one. Where's my marker? Marker went away. Whoa. So, alright. So that is equal to. Oh, we didn't do domain and range on the last one. We'll just do it on this one. Don't let me forget again. -3x minus 7 is less than if x is less than -1. -5 if x is greater than or equal to -1. Okay, so the boundary I'm concerned with on this one is where x is -1. So I'm going to go to my origin. I'm going to move left for -1. I'm just going to put me a little dotted line through that. You don't have to, but it helps me. So that's just my personal preference.
The G times X?
G of x, yes. It's just the same as y. They could put any letter there.
I have a question.
Mhm.
Will that ever, like, be two different numbers, like how it's -1 now? Will it be?
Yeah, it doesn't have to be the same number every time. So I might put more than one dotted line if I needed to.
Oh, okay.
Alright, so on my first line, y equals -3x minus 7. What's my y-intercept? -7. So I gotta go down 7. I don't have a shoot. Alright, I'm having to erase my dotted line because now I'm gonna have to count on every line. So I gotta move that over. Did not plan well on that one. So this is gonna be my -1 line. Alright, so now I'm going down 7. 1, 2, 3, 4, 5, 6, 7. And then the slope on that is, what did it say? How many x's was it? -3, so I can go up 3 and left 1.
But you run into your dotted line.
Right, so does that one have an equal bar underneath it?
No.
No. I'm looking at the wrong one. No, you're correct, Mundo. So when I run into that line, like Kinley said I was gonna do, it doesn't have an equal bar, so I'm gonna leave the circle open.
Oh, crap.
Is that right? Okay, I was hoping somebody would say no.
No.
Okay, good, Jalen. Why is that not right?
It's on the wrong side.
Okay, very good. It said on my rule that I graph that when x is less than -1. Less than -1 will be to the left, so I'm gonna continue this thing going to the left. So let me get one more slope on that. Oops, what the heck is that? Silly Billy. Alright, now we can draw that thing pretty good. What you got, Kinley?
No,
Why not?
I'm really confused.
Tell me about what?
I don't know. I'm just so confused.
Well, you talk about it. Let me try to help you, but you gotta talk to me about it.
Why didn't we connect the other two?
Connect what? Oh,
No.
because, but this one down here,
Yeah.
because that's to the right of -1, which is
Oh,
greater,
okay,
and this,
yeah.
see, good job.
Thanks.
You're welcome. Okay, now my next line says y is equal to -5. So from the origin, y is up and down, so I'll go down 1, 2, 3, 4, 5, and I'll just be a horizontal line through that. But let's see what my boundary is. Which side of the dotted line does it want me to show? Oh, greater than this time, so it wants me to show everything to the right, and it also says equal to. So over here on my dotted line, I'll put a colored in circle since it's equal to, and then greater than goes to the right. Alright, last time I forgot domain and range, so I can't forget it this time. Okay, so domain, that's your x's, that's your left to right. So we know this thing is gonna keep going to the right forever. You with that? Okay, what about this one? Is it gonna keep going left forever? Yeah, it's getting steep, but it's still going to the left, right? So the only question is gonna be if it touches -1 or not. This one does, right? So if they both had an open circle, it wouldn't touch -1. We'd have a different scenario. But this one does touch -1, so x's, it's gonna go everywhere. So you know how to write that. All real numbers, right, for your domain. Okay, range, that's your y, that's your up and down. So you know this dude's gonna go up forever, right? But is it gonna go down forever? No, it's not gonna go any lower than this, is it? So what is that? -5, right? Right? In this 1, 2, 3, 4, 5, it goes no lower than -5, right? Does it touch -5? So it's got to be greater than or equal to -5. So range is y, so y's got to be greater than or equal to -5. Good morning, sunshine.
Good morning. I said your verification sheet's in there.
Well, thank you. Aren't you efficient? You're efficient.
So why is the domain all over the page?
I thought
Because because it's going to go x, it's going to go forever to the right, and it's going to go forever to the left. Because this one keeps going that way.
Okay, so you look at both of them?
Yes, yes.
Don't know why, you just look at.
Well, this one stops here, so it doesn't go any lower than that. And then this one doesn't go any lower than that. Alright, let's do another. Y'all think y'all can try one? I think you can. Let me go ahead and get my paper ready, and then I'll let y'all go try it. That's the one we just did. No, it's not. We'll do this, negative 5/2 x minus 1. If x is less than 2. And then x plus 2. If x is greater than 2. Okay, see if you can graph those and give the domain and range. Uh-huh. Go get it written down, then go try it. Not getting smacked for getting it wrong yet, just go try it. Uh-huh.
How do we get the y-intercept?
It's in the, what's in the B spot, y equals mx plus b.
But there's two different numbers. Like x plus 2 and negative 5 half x plus 1.
So those are two different lines with two different y-intercepts.
So we do figure out y-intercept? Got it some? Got either one of them started? I don't get how to do this one.
What do you have two dotted lines.
I thought you said two liners.
That's, a y-intercept means where you cross the y-axis.
All I had to do is, I was confused. So how do you do your dotted line?
It's on a boundary, so this one's on 2, because it says x is less than 2, x is greater than 2. I think you got one of them going the wrong way is all. That, the one, the negative 5 has x, that's a negative slope, so it should be going downhill. Alright, let's go through our steps together. Remember, the dotted line you don't have to do if it doesn't help you, but it helps me, so I'm going to. But you get your dotted line, I call this part the rule. This is where it's telling you what piece to show. So over here on the rule, it's telling me I'm going to be concerned with where x is 2. So, let's see, I think I can do the reds this time. 1, 2. So there's my dotted line I want to be concerned with. So I'm either going to show stuff to the left of that or to the right of that.
Is that 2 or 4?
2. This first line, when x is less than that, so this first line I want to show to the left of it. Okay, so let's graph the first line. It's got a y-intercept of -1.
Wait, that's 2?
Mm-hmm.
So you're doing every 2 blocks in one?
I counted on the reds this time, like I said. Okay, then from there, your slope is -5/2. So I could go down, 1, 2, come on, scroll with me. 1, 2, 3, 4, 5, and then left 2. Now, on that, it said x is greater than 2, so that would need to be an open circle, because it can't touch 2.
Did you go down 5 over 2?
Because the slope was -5/2, 5 over 2.
I thought you said left 2.
If I would have went left, that would have been a negative over a negative, which is a positive. You know how to graph a line. The only thing we're doing different than what you've graphed a line in the past is we're only showing a piece of it. The graphing the line stuff is still the same. Okay, so this line, I'm only concerned with it on the right of my dotted line. So its B is 2, so I'm gonna go up 2 and put a dot. And then from there, its slope is 1, so I'm gonna rise 1, run 1. But this stuff over here doesn't matter. It wants the stuff on the left, on the right. It wants the greater than. So I'm gonna go up 1 over 1 again. That's on my line. It doesn't have an equal, so it'll be an open circle. And then I'm gonna scroll it up 1 over 1 again.
I'm so confused.
About what?
Where did you get that dot from?
This one?
Yeah.
I went to my y-intercept, which was 2, and then it had a slope of 1, so I rose 1, ran 1, and then rose 1, ran 1 again, and then rose 1, ran 1.
Can you scroll your screen down, please? Where's your point of? Yeah, that's what I need. I need more to go.
So do both the points have to touch the double line?
No. Most of the time they will, unless the instance happens that Kira was talking about if you got 2 different boundaries.
Or is it left?
No? You're supposed to only show pieces of the line. So, whoa, right there. Now go down to your other one and erase the stuff. Yes. Yes, like that. Okay, so let's talk about the domain and the range.
We've done these all real numbers.
Okay, so Riley says the domain's gonna be all real numbers, and that's close. It's not right this time. Look at your boundary. Look at the 2. Does this line up here at the top touch 2?
Yes.
No, it's
Alright.
open circle, so it's not touching it, is it? Does this one down here at the bottom touch 2?
Nope.
No, because it's an open circle, so it's going forever to the left on this line. And then this one, my line up at the top, it's going forever to the right, but it doesn't touch 2. So my domain would be all of the x's except for 2. So x can be anything except for 2.
So that,
Put the slash through the equals.
wait, so. Domain X.
Okay, now in our range, this line up here is gonna go up forever, but there's nothing below it. Oh, but wait, there is stuff below it, cause this line over here is gonna go up forever. So what's the lowest these 2 lines can go? Right here, which was negative 1, 2, 3, 4, 5, 6. So my range, can it be negative 6? No, it's an open circle, so it's gotta be greater than negative 6.
So it doesn't matter how high it goes, just how low it is?
Well, if it's, this one doesn't matter how high it goes because these lines keep going forever. If they had been turned over and going down, then it would have had to been less than something. Good job. Alright, so the graphing of the line part's not new, not different. It's just now just showing the pieces. That's why it's called a piecewise function. Okay? There is a homework for this. I would say it's probably a good one for you to get some practice on. It's up to you though. You don't know you don't have to if you don't want to. But I can tell you the people that have been doing better on the test usually have done some homework. So
Where
they,
is it at?
they learn more and they get bonus points. It's a win-win. Okay?